The Webb Telescope has detected the atmosphere around a rocky planet outside our solar system. Astronomers using the James Webb Space Telescope discovered the atmosphere on the rocky exoplanet 55 Cancri, 41 light-years away from Earth. It is the first rocky planet outside the solar system where the existence of an atmosphere has been confirmed. 55 Cancri is one of 5 known planets orbiting 55 Cancri, a Sun-like star located in the constellation of Cancer. This planet is classified as the so-called super-Earth. It has a diameter almost twice that of our planet and a mass 8 times greater. It is probably similar in composition to the terrestrial planets in our solar system. The planet is in a very tight orbit. They will orbit their star in 18 hours at a distance of about 2.25 million kilometers. That's 1/25 of the distance between Mercury and the Sun. For this reason, its surface is an ocean of molten rocks. In such a tight orbit, the planet behaves like our Moon, with the day side always facing the star and the night side immersed in eternal darkness. In 2015, as a result of a public competition, the planet was named Janssen, which commemorates the Dutch designer of the first optical microscope, Zachariah Janssen. The researcher is also credited with developing the telescope. In the same competition, the home star of the planet Janssen was named Copernicus in honor of Nicolaus Copernicus. Unlike the atmospheres of gas giants, which are relatively easy to detect, the thinner and denser atmospheres surrounding rocky planets are difficult to detect. Given the tight orbit, high temperature on Janssen's surface and the constant flood of radiation from the star, astronomers doubted an atmosphere could be formed and maintained there. However, previous studies of 55 Cancri using data from the now-defunct Spitzer Space Telescope suggested the presence of an atmosphere rich in volatile substances such as oxygen, nitrogen and carbon dioxide. But the data collected was uncertain, and researchers couldn't rule out another possibility: that the planet is naked except for a thin shroud of evaporated rocks, rich in elements such as silicon, iron, aluminum and calcium. The planet is so hot that some of the molten rock should evaporate, explained vwneU of NASA's Jet Propulsion Laboratory, JPL. Lead author of a recent paper on the atmosphere on 55 Cancri, which appeared in Nature, DOI 10.1038, S41586, 024, 07432X. To determine whether Janssen has an atmosphere, scientists used the James Webb Space Telescope, JWST, and its infrared observations. Although Webb cannot capture a direct image of 55 Cancri, it can measure subtle changes in the light of the entire system as the planet orbits the star. The first indication that 55 Cancri might have a significant atmosphere came from temperature measurements based on thermal emissions, which is thermal energy given off in the form of infrared light. If the planet is actually covered with dark, molten rock with a thin covering of evaporated rock, or no atmosphere at all, The temperature on the day side should be around 2200 degrees Celsius. Instead, JWST data showed a much lower temperature of around 1540 degrees Celsius. This is a very clear indication that energy is being distributed from the day side to the night side, most likely through an atmosphere rich in volatiles, Hu said. Heat could also be transported using lava, but, researchers say, this process would not be able to transfer it efficiently enough to explain the cooling effect. In turn, data collected by the NIR-CAM instrument on JWST showed that less light with wavelengths between 4 and 5 microns was reaching the telescope. This suggests the presence of an atmosphere containing carbon monoxide or carbon dioxide that absorbs light at these wavelengths, explained co-author Aaron Bello-Arufe of JPL. A planet without an atmosphere or with only evaporated rocks in its atmosphere would not have these spectral features. The team believes that the gases covering 55 Cancri are not its original atmosphere, as it would have long since disappeared due to the star's high temperature and intense radiation. It's a secondary atmosphere, constantly being replenished by an ocean of lava, and it's not just molten rock, there's a lot of dissolved gas in it, Bello-Arufe said. In addition to carbon monoxide and dioxide, it may also contain nitrogen, water vapor, sulfur dioxide, evaporated rocks, and even short-lived clouds made of tiny droplets of lava condensed from the air. Although 55 Cancri is far too hot to support life as we know it, scientists believe it could provide a unique window into the interactions between the atmospheres, surfaces and interiors of terrestrial planets, and perhaps provide insight into the early Earth, Venus and Mars, which are also believed to have been covered in oceans of molten rock in the past.